to all of you. Today in this session we will be discussing representation and normalization of wave function. Before I start, let me know if everything is all right.
Representation and normalization of
Everything all right? Can we start today's session? Look, this session is very important and easy too. Actually, we missed this session somehow. We should have done it before. But anyway, the advantage of this will be you will find it very easy because we have already done complicated topics before. So if we talk about the representation of wave function, it starts with writing the wave function into spatial and time part. So you know the solution of the Schrodinger equation, if I write psi of xt, so the complete representation of wave function is, you see it has some spatial part related to x and its time evolution. Time evolution is done in this way: e to the power minus I e t by h cut. Now you know E is equals to h cut omega, so we can write psi of x e to the power minus I omega t. Okay, so both the form are useful, especially the first form, psi of x e to the power minus I e t by h cut. So you have to remember this. This will help us to describe the time evolution of the wave function. Okay, good morning, Harry. Let's start with the problem. Look, the wave function of a particle at time t equals to 0 is given by psi of 0 1 by root 2 this, where e1 e2 are normalized eigenstates with energy eigenvalues e1 and e2. e2 is greater than e1. The shortest time after which psi t will become orthogonal to psi 0. So you know the condition of orthogonality. If two state vectors are orthogonal, you know their scalar product is 0. So you will have psi 0 psi t, it is equals to 0. This is the orthogonal condition, orthogonality condition. So will you give it a try? Look, what is given at time t equals to 0. You have been given psi at t equals to 0 1 upon root 2 times u1 plus u2, and furthermore it is given that e1 e2 are the normalized eigenstate with eigenvalues e1 and e2. Okay, so if I write at any time t the wave function will be psi of t. So 1 by root 2 u1, this is the space part, time part e to the power, here you see minus I e t by h cut. Okay, I e t by h cut, this was the form. Here you see t equals to 0, so that is why there is nothing here. Here u1, the corresponding energy eigenvalue is e1, so here it will be I e1 t by h cut plus u2 e to the power minus I energy eigenvalue is e2, so e2 t by h cut. This is at any arbitrary time t. Okay, now the shortest time after which psi t will become orthogonal to psi 0. Okay, when psi t becomes orthogonal to psi 0, we have psi 0 psi t or psi t psi 0, scalar product is 0. B you are getting pi h cut, yes, B will come. Now you see bra psi 0, so this one is 1 by root 2 u1 u2 and get psi t 1 by root 2 square कर देते हैं u1 e to the power minus I e1 t by h cut u2 to the power minus I e2 t by h cut is equal to 0. Now these are normalized eigenstates. So this will become half e to the power minus I e1 t by h cut plus half e to the power minus I e2 t by h cut using the orthonormality condition. U, let's say I u j delta I j 1 if I is equals to j, 0 if I not equals to j. So half is absorbed, so what you are left with e to the power minus I e1 t by h cut is equals to minus e to the power minus I e2 t by h cut. Look, e to the power, if I take I common, this e2 will come here positive and that minus e1 t by h cut will remain. This is minus 1. Okay, minus 1 can be written as e to the power I pi. So if you equate this, you will get e2 minus e1 times t by h cut is equals to pi, and hence we get the value of t to be pi h cut by e2 minus e1, where e2 is greater than e1. So you can also remember this formula. Sometimes you can directly use this formula. T equals to pi h cut by e2 minus e1, and this is precisely matching with option B. Good morning, Murli. I hope everybody understood. Let's go for the next problem. The eigenstate of the Hamiltonian of a quantum mechanical system are phi 1, phi 2 and phi 3 with eigenvalues e0, e2, 2e0, 3e0. At time t equals to 0, the state has the following scalar product. You can see phi 1 psi a1, phi 2 psi a2, phi 3 psi a3. Then phi 1 psi, phi 2 psi, phi 3 psi after time t equals to pi h cut by e naught r respectively. So this is a very similar problem. How will you do this? So you can see eigenstate of a Hamiltonian of a quantum mechanical system are phi 1, phi 2, phi 3 with eigenvalue this. So we can write, look, the state psi has the following scalar product. Phi 1 psi is equals to a1, phi 2 psi is equals to a2, phi 3 psi is equals to a3. So looking at this, we can write that at time t is equals to 0, we have psi of 0, this is equals to, if you multiply phi 1 with psi, you get a1. Okay, so let's start writing psi of 0, let's write psi. So psi is what? Obviously A1, phi 1 will come first. That is why when you take the if you multiply the brass phi 1, it will give you A1 plus phi 2 psi is equals to A2. So obviously this will be A2 phi 2 and plus A3 phi 3. Now at some later time, after time t, the values these scalar products are, means you have to find out, let's say, the coefficients after some time t equals to pi h cut by e naught. So at time t is equals to t, what we will have, let's say psi of t, this will be a1 phi 1 e to the power minus I e1 t by h cut plus a2 phi 2 e to the power minus I e2 t by h cut plus the third term will be a3 phi 3 e to the power minus I e3 t by h cut. So after time t equals to pi h cut by epsilon naught. So when t is equals to pi h cut by e naught, then what will happen? Look, E1 is given to you. So the eigenvalue corresponding to phi 1 is E1, that is E0. Eigenvalue corresponding to phi 2 is E2, that is 2 E naught, and eigenvalue corresponding to phi 3 is E3, that is equals to 3 E naught. So here E1 is equals to E naught, E2 is equals to 2 E naught, and E3 is equals to 3 E naught. What value of phi t you will get? A1 phi 1 e to the power minus I e1, so I e naught t by h cut. Okay. Or I think you should write it. The steep factor will write later. Okay. For the time being, let's replace the energy eigenvalues first. So for E1, E2 and E3, psi t takes the form, okay, plus E2, A2 phi 2 e to the power minus I E2, so minus I, so 2I E naught t by h cut plus A3 phi 3 e to the power minus 3I E naught t by h cut. Okay. This first step I don't understand how the given scalar product condition lead to the first step at time t equals to 0. Okay. Look, at time t equals to 0, state psi has the following scalar product. So looking at this, you know, phi 1 into ket psi is equals to a1. So obviously it will be a1 into phi 1. Then only if you take phi 1 then psi, this will give you a1 phi 1 phi 1, a2 phi 1 phi 2, a3 phi 1 phi 3. So obviously the first term will survive because the orthonormality condition, this term will be 0, this term will be 0. So that is why you will get a1. So let's say a2 into psi is equals to a2. So obviously here phi 2 will come, so a2 will survive, phi 2 phi 1 phi 2 phi 3 will be 0. So by looking at this product we formulate psi, that psi must be of the form like this. Okay. Now this one at time t is equals to pi h cut by E naught. What we'll have? We'll have psi t. Psi t. Okay, so we can also write it in this way. Psi of t at pi h cut by E naught. A1 phi 1 e to the power minus. If you put E1 is equals to pi h cut by E naught, what you are left with? E to the power minus I pi plus A2 phi 2 e to the power minus 2 pi I, and here you will get it e to the power minus 3 pi I. E to the power minus I pi is minus 1, so minus A1 phi 1 plus A2 phi 2, and this minus 3 pi, so it is minus again A3 phi 3. So what will be the product after some time? So from this we can say that phi 1 psi will be minus A1, phi 2 psi will be A2, and phi 3 psi will be minus A3, and that is matching with option D, minus A1 plus A2 minus A3. Is it clear? Simple question. If anyone has any question, you can ask. Okay, if it is done, let's move forward for this problem. A quantum mechanical particle in a harmonic oscillator potential has initial wave function psi 0 x plus psi 1 x. Psi 0, psi 1 are the real wave functions in the ground state and the first excited state. Ground state and the first excited state. You can take, for convenience, m is equals to h cut is equals to omega equals to 1. So this will make our calculation a little bit simpler for the oscillator. What is the probability density? Probability density mod psi square of finding the particle at position x and at time t equals to pi. Okay, so you have to find out the probability density at time t is equals to pi. Understood? Do it. Look, the initial wave function is given to be, let's say the initial wave function we are denoted by psi of x. This is psi 0 x plus psi 1 x. Psi 0, psi 1 are the real wave function in the ground state and the first excited state of the harmonic oscillator. So if this is psi of x, what will be the value of psi of xt? Let's say psi of xt will be psi 0 of x, then the time part is the power minus I e naught t by h cut plus psi 1 of x e to the power minus I e1 t by h cut. So what is the probability density of time? Probability density of finding the particle at position t at some time t equals to pi. So let's calculate first the probability density at any arbitrary time t equals to t. Okay, you can take m, h cut, omega, all of them to be 1. So the probability density at time t is given by square of it, okay, mod psi of xt square. So this is psi star of xt times psi of xt. This is the formula of mod square. So psi star is psi 0 of x e to the power I e naught t by h cut. So psi star means just replacing I with minus I. Wherever you see I, you just replace it with minus I. Okay, so this is psi star and psi is this psi 0 minus I e naught t by h cut psi 1 I e1 t by h cut. Okay, so this is, you see, this is mod psi 0 of x square plus mod psi 1 of x square plus, you see, it is psi 0 actually this is psi 0 star, this is psi 1 star, psi 0 star psi 1 x e to the power minus I e1 t h cut and psi 1 star psi 0 x e to the power minus this product. So this can be written as 2 times psi 0 star x psi 1 x cos e1 minus e0 t by h cut. And psi 0, psi 1 are given a real wave function. So psi 0 is star and psi 0, okay, even if you do not write a star because they are real, so psi 0, psi 1 star you can remove. Now h cut is given to be 1, so you can also put h cut equals to 1. So putting sorry, t is equals to pi, t equals to pi, h cut equals to 1 and nothing else, we get mod psi of xt whole square psi 0 x psi 1 x 2 times psi 0 x psi 1 x this is cos E1 minus E0. So you know, in harmonic oscillator, what is the difference between the two energies E0, E1? You know that energy difference is h cut omega. So h cut omega, so it is cos omega t. Okay, and omega is given to be 1. So this becomes cos pi. E1 minus E0 is equals to h cut omega, so equals to 1. Both h cut and omega are 1. So this is mod psi 0 x square mod psi 1 x square minus 2 times psi 0 x psi 1 x cos pi is minus 1. So this can be written as psi 1 x minus psi 0 x square, matching with option A. Clear? Let's move on to this question. Very simple question. The Hermitian operator A has two normalized eigenstates, 1 and 2 with eigenvalues 1 and 2 respectively. If any state psi is defined as psi is equals to cos phi 1 plus sin phi 2, the value of psi SI is 7/4. What is the value of phi? Can you do it? First of all, let us write what is given to us. You are given that the operator A has two normalized eigenstates 1 and 2 with eigenvalues 1 and 2. So if you apply A 1 state 1, you get eigenvalue 1. This is how we write. If you apply A 1 2, you get 2. So this is what is given. Any state psi is written to be ket psi cos phi ket 1 plus sin phi ket 2. So the value of the expectation value of A is given to be 7/4. Then what is the value of phi that we need to find out? So to do this, we can use this condition of the expectation value. Okay, psi A psi is equals to 7/4. We can use that. Psi A psi, this is equals to, you have bra psi and here you have ket psi. So bra psi will be 1 cos phi 2 sin phi. So let's write 1 cos phi plus 2 sin phi. A applying on psi. So A applying on psi cos phi, A applying on 1. So A applying on 1 is 1 into 1. So this becomes cos phi 1 sin phi 2, A applying on 2. So this will become 2 sin phi 2. Okay. Now using the orthonormality condition, so orthonormality condition is mn delta mn. So this is 1 when m is equals to n, 0 otherwise. is the orthonormality condition. So 1 1, that is 1, so cos square phi plus here sin phi 2 sin phi, so 2 sin square phi, and this is given to you to be 7/4. Cos square phi 2 sin square phi is given to you 7/4. So from this you need to find out the value of phi. So cos square phi, if you take 1 sin square phi, then that will become 1, and 1 sin square phi will remain. Right? So from this, sin square phi is equals to 7/4 minus 1. So 7/4 minus 1 is 3/4. And from this, we get sin phi square root of 3/2, and you know the value of phi, for which sin phi is 3/2. Sin inverse square root of 3/2. So 60 degree means pi/3. C. Clear? Let's move on to the next question. If the expectation value of the momentum is p for the wave function psi of x, then the expectation value of momentum for the wave function e to the power I k x by h cut psi x each. Understood the question? The question says expectation value of the momentum is p for the wave function psi x, means psi x p psi x, this is p, then e to the power I k x by h cut psi x. So actually this will become minus bracket psi p e to the power I k x, this is equals to how much? Actually this is what it is asking precisely. Get it? So it is straightforward. Maybe the calculation may be little bit appear to be little bit difficult, but the process is simple. So let's denote the new wave function by psi prime x. Let's denote the new wave function by psi prime x, which is e to the power I k x by h cut psi of x. So it is like calculating psi prime x p psi prime x. Okay. So you know the momentum operator p. Momentum operator p is minus I h cut d d x. This is in one dimension. Psi of x, so it is in one dimension. So p is equals to minus I h cut d dx. So the expectation value of momentum for the wave function this psi prime. Therefore, the expectation value of momentum for the wave function psi prime of x is. Look, we will write p prime. So this is equals to psi prime of x p, let's say p prime psi of x. P prime, just to make it different from p, this p and p prime will be same, this operator value will be same, but this overall value will be different. That is why we are writing it by p prime. Okay. Okay, let's not denote this p prime. Okay, the wave function is changing, so automatically the momentum expectation value will change. So this is equals to minus infinity to plus infinity psi prime star x p is equals to minus I h cut d dx psi prime of x dx. You can write it in this way. Now let's substitute. Psi star means e to the power minus I k x by h cut psi of x minus I h cut d dx of psi prime. Okay. Minus infinity to plus infinity to the power minus I k x by h cut psi of x, and you can see minus I h cut d dx of this whole thing. So I k by h cut e to the power I k x by h cut psi of x, another term will come, that is e to the power I k x by h cut d psi by dx, and that dx will remain multiplied as it is. This is equals to how much? Achha, this will be psi star now. Is it clear till now? This becomes minus infinity to plus infinity psi star x. You have this I h cut everything will get cancelled, so we will have k psi of x minus I h cut d psi by dx. Exponential term is getting vanished dx. Now this can be separated into two terms, minus infinity to plus infinity psi star x minus I h cut d psi by dx time dx plus k times minus infinity to plus infinity psi star x psi of x dx. And as you can see, the first term is nothing but the expectation value of momentum psi star x, minus I square d dx of psi dx. So this is expectation value of momentum plus k times what is this, minus infinity plus infinity psi star psi x dx. This is the normalization condition, that is 1. Okay. So that is why it is matching with option C. Clear? Can you move forward? If anyone has any question, you can ask. Do this one. If a particle is represented by the normalized wave function given by this, find p square. Expectation value of p square you have to calculate. Look, if I write p, operator p minus I h cut d dx. So p square will become minus h cut square d square upon dx square. So what is the expectation value of p square? This will be psi p square psi, and this is normalized wave function, so divided by psi is not there. Okay, so you have to always apply this one because psi is normalized, so we can directly write it like this. Now the value of psi is given to you. Okay, minus infinity to plus infinity psi star p square psi dx. This is equals to, you see, the value of psi is non-zero only between minus a to plus a. So the integration limit will be modified to minus a to plus a. Minus h cut square is coming outside. 15 by 4 a to the power 5 by 2 was there, na? It is appearing twice. So 4 a to the power 5. 4 square a to the power 5. So 16. 16 a to the power 5 by 2, so it is about 5 minus a to plus a. You are left with a square minus x square for psi star, and for psi we have to do it d square by dx square. Psi means a square minus x square dx. Okay, this is equals to minus h cut square 15 by 16 a to the power 5. This one, what it will give you? minus a to plus a square minus x square, d square by dx square, a square minus x square. So derivative with respect to x, so minus 2x minus 2, so this becomes minus 2, right? Minus minus plus, so it becomes h cot square 15 by 2 and 16, so 8, a to the power 5 minus a to plus a square minus x square dx. So the integration of dx is x cube by 3 minus a to plus a. Or you can also write, because this is an even function, we can also do one thing. We can just write it 2 times 0 to a square minus x square dx. So again the 1 2 is cancelled with say 8, making it 8, and this 2 will make it 4. So 15 h cot square by 4 a to the power 5, this is a square x minus x cube by 3, 0 to a. So 15 h cot square divided by 4 a to the power 5, this is a cube minus a cube by 3. So 15 h cot square by 4 a to the power 5, 2 a cube by 3. So 2 2 3 5. So what you are left with? 5 h cot square by 2 a to the power cube and 5, so it will become a square. Five h cot square divided by 2a square, option A. So that 16 to be written in denominator, yes, 4 into 4 16, 16, 2 and 16 8, 2 and 8 4. Is it clear now? Fifth state, 1 2 3 4 fifth. This one, this 16 is becoming 8 now. Third step from bottom. This one, this minus 2 and minus this becomes 8. 2 also multiply. This 2 is coming because of we have changed the limit from minus a to 2 times 0 to a. This 2 is coming by changing the limits, and that this 2 is making 8. Okay, so 2 and 8 4 again. This is matching with option A. Again, although we have already talked about normalization, let's talk about it again. Normalization. So you already know the meaning of normalization, right? So let me reiterate it again. The statistical interpretation. Statistical interpretation of the wave function statistical interpretation of the wave function which says that mod psi of xt whole square is the probability density for finding the particle at point x at time t. The integral of mod psi of xt whole square must be 1. The meaning of this, the particle needs to be somewhere. Okay, particle is got to be somewhere. So the normalization condition is given by minus infinity to plus infinity mod psi of xt square dx equals to 1. You can imagine it in this way, that we have the probability amplitude. Okay, so let's say mod of psi xt, this is versus x. So you see, the probability of finding the particle will be high here. Probability of finding the particle will be low comparatively here, and it is diminishing here, you can see. But you see, the total probability, total means what? It will be calculated in this form, that the area under this curve. So if you scan over the whole space, the particle will definitely be found somewhere. Okay, because at any place the particle will be there. If not here, if not here, at any place it will be here. If you scan the whole space from minus infinity to plus infinity, the particle definitely be there. That is a certain event. That is why the total probability is 1. If you integrate minus infinity to plus infinity, you are certain that you will get the particle. That is why this integration is 1. Now if I say that what is the probability to find the particle between, let's say, x1 and x2. So what is this part of probability? So you have to scan for this region only, and what will be that probability? If you integrate the probability density in this region, so this region will be the probability to find the particle between x1 and x2. So if I tell you the probability to find the particle between x1 and x2 is, what will be that? Probability density, you have to take the integration of the probability density to probability to find the particle between x1 and x2 at time, let's say t. What you gonna do? You have to take the integration of the probability density between x1 and x2. This will not be 1, because you see, if you scan over the whole space, then it will be 1. So obviously we are scanning over a limited space, obviously this will be less than 1. This must be less than 1. Clear? It may have some value, but it will be definitely be less than 1. Did you get the concept of probability density and normalization. Karthik, Harry, where is Harry? Murli, if people are understanding this, let's do this one. The normalizing constant A for the given wave function is look, mod x less equals to A. What does it mean? The condition here is given little bit in a tricky manner. A times A minus mod x when mod x less equals to A and when mod x greater than A, right? Mod x less equals to A, less than 1, not equal to 0. Yes, it will not be equals to 0. At whichever point you do the do this scanning, there will be some finite probability. It may be very close to 0, but not exactly equals to 0. But situation may appear like if you consider, let's say, particle in a box. For the particle in a box problem, let's say with 0 to L. So if you find the probability to find the particle, let's say between more than L, 2L to 3L, let's say, that will be 0. If you go on the other side, if you go x less than 0 or x greater than 0, whatever you do, that will be equals to 0. So it will depend. Okay. Now this meaning of mod x less equals to A, what does it mean? It means, you see, x less equals to A or x greater equals to minus A, isn't it? That is what the meaning of it. On mod x greater than A, it means x greater than A, x less than minus A. So if you consider a region like this, this is, let's say, minus A, this is plus A, and it is going to infinity, minus infinity. So this non-zero value is there between minus A to plus A, right? In this region only the non-zero value is. For other region it is 0. Okay, this is the region. The other regions, let's say this mod x greater than A is this. Is there no other color? Same. So this can be redefined in this way. We can write it in this way. This is equals to a times a minus x. Okay, minus a to a. So it has further sub classification. One is minus a to 0. This region is x less than 0, and 0 to a, this region is x greater than a. Sorry, x greater than 0. So if you consider x greater than 0, when 0 to a, this becomes a into a minus x. This will 0 and a, and this is a into a plus x minus minus plus. If you consider minus a to 0, and in other region it is vanishing. So this condition is the main complication here in this problem. Is it clear now? Now you have to find out this normalization condition constant a. So we can use the normalization condition. Normalization condition minus infinity to plus infinity mod psi of x whole square dx is equals to 1. So minus infinity to plus infinity psi star x psi x dx is equals to 1. Now it is valid between 0 to a, and it is real function. So a will come out to be a square, taking it outside. 0 to minus a to 0, a into, so a we have already taken common, a plus x whole square dx, 0 to a minus x whole square dx is to 1. Okay. Now let's say x is equals to minus t. So you see dx is equals to minus dt. If it is so, we can change the limit of integration x. Let's say it was before minus a to 0. When you make it t, it becomes a to 0. Okay. One time explain mod condition. How do you split? Mod condition second line or third line you are asking, because mod is square, mod psi square is psi star psi. This is what we know. Now this one, you see it is minus infinity to plus infinity, but the value is non-zero between minus a to plus a. So first we wrote for minus a to 0, minus a to 0. So here the value is a into a plus x, so a plus x whole square. Between 0 to a, the value is a minus x, so that is why. How it is a into a minus x and a into a plus x for the conditions. Okay. Here it is mod x, right? So what is the value of mod x? Mod x is equals to plus x when x is positive, and it is minus x when x negative. Okay. So x less equals to a, mod x less equals to a corresponds to this region minus a to plus a. Now in this region we have x less than 0 between minus a to 0, and you get x greater than 0, 0 to a. So when we are considering minus a to 0, x less than 0 condition means we have to put minus x. So a minus of minus x, a plus x. X greater than 0, 0 to a, you know, mod x equals to x. So a minus x. Mod it is automatically x is less than 0 or greater than 0. No. The definition of mod x is this. It is equals to x when x is positive, and it is equals to minus x when x is negative. This is the definition of modulus. Mod means, look, the thing is, it is minus, let's say, mod x. Then you can write it plus x. Now it will depend in which region you take this x. Okay, na? So this is x line, 0. So if you take the x values in this region, obviously it will be minus x. This will be plus x. So it just remove this minus if it has any. Two conditions written above the drawn diagram. Yeah, this one. Mod x less equals to a. Okay. So using this condition, x less equals to a, and you see x greater equals to minus a, because x less equals to, it is actually this condition. You see mod x, so you have minus x. So minus x less equals to a means x greater equals to minus a, because by definition mod x will come out as plus x and minus x. So you see mod x, when we are considering it to be plus x, so this is less equals to a. Now mod x equals to minus x. Okay, this is also less equals to a. So that means x greater equals to minus a. That is why we have written this. Here also mod x greater than a, it means x greater than a, minus x also greater than a. Here mod x, by definition, it is giving you minus x greater than a and x greater than a. X greater than a is natural. Minus x greater than a means x less than minus a. Now understood? Any more confusion? These are simple math of class 12, right? We learned it in class 12. So we can write mod a square. As you can see, it becoming a to 0. So we can change the limit from 0 to a. Zero to a minus x square dx plus 0 to a minus x square dx is equals to 1. Can I write it? Look, the integration limit was coming a to 0, but here this minus sign is also there, so that is why it becomes 0 to a. I hope this is clear. After replacing this, let's say this first integration will become minus a to 0, so a plus x square dx, this becomes a to 0, a minus t whole square dx is minus dt. So this is equals to 0 to a minus t mod square dt. This minus sign just changes the limit. So it is equivalent to writing 0 to a minus x square dx. I hope this makes sense. So these two integral are equal. So 2 times mod a square 0 to a minus x square dx, this is equals to 1, 2 mod a square minus 2ax plus x square dx 2 a square, this is a square x minus a x square plus x cube by 3, 0 to a. This is equals to 1. That means 2 a square, and this will give you a cube by 3 equals to 1. A equals to 3 by 2a cube square root, matching with option B. Look, you have to practice these questions, okay? Otherwise you may get confused. I have tried to explain each and every step. In book you will not get it so straightforward, so step by step. The next problem is, I think you have already done this type of problem before. A quantum mechanical particle has the initial wave function this, psi 0 psi 1 real wave function of the ground and first excited state of the Hamiltonian with energy E0n. What is the expression of the probability density at time t? So I think we have done it already, na? Psi of x, psi 0 of x, psi 1 of x, so psi of xt, psi 0 of x, I E0 t by h cut, I E1 t by h cut. So what is the expression of probability density at time t? So the probability density is mod psi of xt whole square. So this is taking this thing's mod. And you know what is mod psi square? It is psi star psi, okay? And psi 0, psi 1, these are real wave function. It is given to you. Real wave function means psi 0 star is equals to psi 0, psi 1 star is equals to psi 1. So you can write, let's say psi 0 star is psi 0, okay, e to the power I E0 t by h cut, psi 1 star is psi 1, e to the power I E1 t by h cut multiplied by again so psi 0 and psi 0 mod psi 0 star mod psi 0 x square, psi 1 x e to the power exponential parts becoming 1, so mod psi 1 square plus, you see psi 0 psi 1 e to the power this and e to the power this, psi 1 psi 0 and same thing, so you can write 2 times psi 0 x psi 1 of x cos E1 minus E0 by h cut into t. Okay, because you know e to the power I theta plus e to the power minus I theta divided by 2 which equals to cos theta. So e to the power I theta plus e to the power minus I theta is 2 cos theta, and that is why we get this factor of 2. And this is matching with option A. One. Look, the options are very close to each other. Don't get confused. Otherwise, you will make mistake. Here it is plus, not minus. Got it? Let's move on to the next question. Today we are solving many problems. At t equals to 0, a particle is in the potential v of x equals to half m omega square x square, and its wave function is this. N is the energy eigenstate with energy. So half actually this is harmonic oscillator. Na? The value of a such that psi is normalized is equal to. Simple problem. The value of a such that psi is normalization. Psi is normalized. So let's apply normalization condition. Normalization condition states that mod psi equals to 1. This is what the normalization condition. In terms of integration, we can write minus infinity to plus infinity psi star psi dx equals to 1. So that is equivalent to writing psi is equals to 1. But here the kets are involved, so instead of using the integration formula, we'll use this first formula. Okay. So if psi is equals to 1, you can say mod a square limit to the limit over n 1 by root 3 to the power n. So 1 by root 3 to the power n, so it becomes 2n. Bra n ket n, that is 1, so this is equals to 1. So mod a square sum over n, this becomes 1 by 3 to the power n equals to 1. Now you know, if you put n is equals to it is an harmonic oscillator, so n starts from 0. So 1 by 3, so 1 plus 1 by 3 plus 1 by 3 whole square plus 1 by 3 cube, so it is 1. This is the formula. 1 minus x inverse, it is 1 plus x square plus x cube and so on. This is the formula we know. So this is 1 by 1 minus x. So 1 by 1 minus x is 1 by 3. So this is 2 by 3, so 3 by 2, 2 by 3. A is equals to square root of 2 by 3. Matching with option D. Simple problem it was. I hope this is clear. Let us now focus on this problem. The operator ddx minus x ddx plus x is equivalent. Look, as I told you earlier also, whenever you deal with this kind of operator involving derivative and all, you need to apply it on some wave function psi, otherwise you will make mistake. Okay, not any wave function, you can apply it on any function. So you have to find out this operator to be equivalent to. So for the time being, let's say we are applying it some operator, some function f of x. Okay, so after calculation you will get something into f of x. Okay, so that something will be the answer, right? So you have to find out this. So let's start with this one, ddx minus x times ddx plus x of f of x. So we can write it, let's say ddx minus x ddx plus x applying on f. So this is df by dx plus x times f. Let's not write f of x every time. A you are getting? Look, A will not come. Let me show you how. So this will give you ddx applying on df by dx plus x into f minus x times df by dx minus x square f. Okay, this is equals to d square f by dx square plus dx by dx is 1, so f plus x times df by dx minus x times df by dx minus x square f. Now this term is getting cancelled, so you are left with d square f by dx square plus f minus x square f. So we can write it as d square by dx square minus x square plus 1 into f, means f of x. Okay, so we can say that ddx minus x ddx plus x equivalent to d square by dx square minus x square plus 1. So you see this algebraically it is looking like d square by dx square minus x square, but this extra plus 1 factor will come because of this behavior of this operator. So option B is the correct option. Tell me if there is any confusion. If you do not apply on f, it will appear to be like the answer will be d square by dx square minus x square, but that is not. Plus 1 term will also be there. Clear? So we have one more problem, then we'll wrap up the session. This is the last problem for today's session. Psi of xt is equals to alpha x e to the power minus beta x e to the power I gamma t by h cut when x greater than 0 and for x less than 0 it is 0. Alpha, beta, gamma are positive constant, then what is the potential B of x? So this kind of question comes many times. It came many times, not only in CSIR-NET but in TIFR also. This kind of question has been set previously. Very simple question. We'll just put it into the Schrodinger equation, then our job will be done. So what is given? We are given psi of xt, it is equals to, you see, alpha x e to the power minus beta x e to the power I gamma t by h cut. This is for x greater than 0 and it is 0 for x less than 0. Okay, Now we can use here, because it is dependent on time, the function is given to be dependent on time, so we have to use the time dependent Schrodinger equation. We know the time dependent Schrodinger equation. So what is that? It is minus h cut square by 2m d square psi by dx square plus v of x psi. Instead of writing e psi, we write it in the form of operator. E is the energy operator is written as I h cut del t. Okay, this is the energy operator into psi. Now psi is a function of x and t, so it will not be a good idea to write d square. You have to write del. Okay, partial, it becomes partial because psi is a function of more than one variable. So if you solve this, we can easily calculate this v of x. So minus h cut square by 2m del square psi by del x square. What you can write? Let's say del x. Now d psi by dx. So derivative with respect to x. So how many terms you will get? You will get here two terms. Alpha e to the power minus beta x. Okay. E to the power I gamma t by h cut. Next, minus alpha beta x e to the power minus beta x to the power I gamma t by h cut. Okay, plus v of x into psi is equals to I h cut del psi by del t. So alpha x e to the power minus beta x related part is not affected, e to the power I gamma t by h cut. So I gamma by h cut e to the power I gamma t by h cut. Okay, this is equals to minus h cut square by 2m. Now this e to the power I gamma t by h cut is not dependent on x, so we can keep it outside. So you are left with del x of alpha e to the power minus beta x minus alpha beta x e to the power minus beta x. Okay, plus okay e to the power I gamma t by h cut plus v of x psi is equals to, you see this h cut get cancelled, I square minus 1 minus gamma alpha x e to the power minus beta x e to the power I gamma t by h cut, that is nothing but psi, right? So we can write minus gamma psi. Now minus h cut square by 2m, this one, what it will give you? Derivative of this thing. Alpha minus beta e to the power minus beta x minus okay alpha beta e to the power minus beta x minus plus alpha beta square x e to the power minus beta x. I am trying to do each and every step, okay, so that you understand it with ease. V of x psi gamma psi. Next, minus h cut square by 2m. Look, minus alpha beta it is minus beta x, minus alpha beta it is minus beta x. So minus 2 alpha beta e to the power minus beta x, and here it is alpha beta square x e to the power minus beta x, okay, multiplied by e to the power I gamma t by h cut plus v of x psi minus gamma psi. Now you see alpha beta x e to the power minus beta x, that is e to the power I gamma t by h cut, that is psi, right? So here x is missing, so if I multiply x, so we have to divide by x, right? Because psi is alpha x e to the power minus beta x, right? So this x was missing, so we have just multiplied by x. So alpha x e to the power minus beta x e to the power I gamma t by h cut, that is psi. So this becomes minus h cut square by 2m. You see, minus 2 beta by x into psi plus alpha x, so beta square into psi plus v of x psi minus gamma psi. You see, e to the power I gamma t along with alpha x e to the power minus beta x makes it psi. So from this, what is v of x? V of x is nothing but, you see, minus gamma and this one plus h cut square by 2m by taking minus common, okay. So you are getting beta square minus 2 beta by x. This one going on the other side becoming plus. So I may be covering it, but I don't have any way. V of x is equals to minus gamma plus h cut square by 2m beta square minus 2 beta by x, and that is matching with option B. Tell me if it is done. Okay guys, so this is all for this session. I hope you find this session useful and you have understood each and everything. Thank you for joining. Bye bye. Take care. Any question if you have, you can ask. Otherwise, I'm ending the session. Any confusion at any part of this calculation? Clear?